the study guide at the end of class. If you guys have any questions about that, you can ask them. Yes, we ended last time with AC Pagoo, the guy who came up with the idea for Pagoovian taxes and subsidies, basically saying that there is a problem, that we may not actually hit a tax or a subsidy that's equal to the externality being caused. So there are some drawbacks to using those. Let's start by walking through an example of a time that people or the government imposes a Pagoovian tax. So both cigarettes and soda have negative externalities. And unlike pollution, these aren't negative externalities in the production, but it's negative externalities in the consumption of these goods. So when people consume them, there are some costs that the rest of society bears, but they don't bear the entire cost of it. So again, we'll expect to see some overconsumption of these goods, of cigarettes and soda. So both cigarettes and soda have these negative health consequences. So cigarettes, obviously you get lung damage for smoking them. For soda, causes obesity, and there's a lot of medical conditions associated with obesity. But just health conditions in and of themselves, just these issues with people, aren't enough to cause a negative externality. If people are the sole person in society to bear the negative costs of their poor health, then they're going to take into account the cost completely. It's when those costs of negative health are shifted to the rest of society or to other people in society that these negative externalities exist. In reality, people don't bear the entire cost of their of medical procedures, of health issues, things like that. So it's either through government insurance or through private group insurance that other people end up being negatively affected by someone else's poor health. So we can say there is a negative externality for both cigarette consumption and for soda consumption. So in theory, they're good candidates for Pagoovian taxes. Because there's this negative externality that exists in their consumption, the government could step in, impose a Pagoovian tax, force consumers to bear a greater cost, more closely in line with what their actual costs are. Then take into account the costs they're imposing on other people in society. The textbook asks, in general, cigarettes are taxed more heavily than soda. Do you think this is appropriate? Are the negative externalities associated with cigarettes greater than the negative externality associated with soda consumption?
If you smoke a cigarette, like to smoke when you affect other people that you drink soda.
So besides prolonged consumption that leads to some like obesity and some health outcomes, you're saying the externality is going to be much lower because of cigarette smoke, because of the secondhand smoke. I like that. That's okay. I guess we'll look at what the soda tax looks like in real life, and then we'll move on to answering that question. So a lot of places don't have soda taxes. Big cities recently, a few of them have passed soda taxes that have really upset people. The one in Philly a couple years ago was really funny because people were going just outside of city limits and purchasing soda for like the cheap price. And like the city government was shocked that this was going on. As you understand incentives, you know, it should be pretty obvious that people be willing to drive just outside the city to buy cheaper soda. Basically what they're doing here, this demand curve here, D1, is the private benefit of soda before the tax. Soda in general tastes good. People like it. Sometimes it has caffeine, which is really helpful right now for us. But there's this added cost from health-related issues caused by obesity. Because we have insurance that pays for a lot of medical treatment, other people have to bear the cost, whether it's through private insurance or through government insurance program. So social benefit is down here. If we're taking into account those costs for the rest of society, the demand curve would be lower. But again, because it's being spread out, people aren't taking that into account. Now, if we place a tax that's equal to the amount of the externality, and we can push that demand curve for individuals down to the demand curve for society, so that they're now consuming an appropriate amount of soda. They're taking into account the cost to the rest of society. Before the quantity was out here, now we're back to the efficient quantity, where the demand curve crosses this flat curve. So the demand curve for all of society, and now the demand curve for private individuals after the tax has been imposed. The consumers are going to pay this price up here, the equilibrium efficient quantity, where that crosses their demand curve, the original demand curve, and then the price that firms are going to receive is going to be that price minus the amount of the tax. So consumers are paying more, encouraging them to consume less, and producers are making less money because of that tax. So they're going to produce less. So by imposing this Pigouvian tax, we end up decreasing the amount of soda that consumers are purchasing and they're consuming. And basically by increasing the price paid. So we're bringing in line the private demand, the private benefit that they're receiving, in line with the demand for society, how much society would prefer. Okay, I guess it doesn't include a slide, but it is mentioned in the textbook that some research has shown that cigarette smoking, and just in terms of health, has less of an externality than prolonged soda consumption and obesity. Kip Viscusi, who does a lot of cool work, he and I'm blanking on Ali's first name, they work on the statistical value of a human life, trying to estimate how much value people place on their lives. Basically by looking at all the ways, how much money people spend on safety measures and like healthcare, things like that, to try to protect and extend their lives. So when you see people talk about like cost-benefit analysis for different COVID restrictions, whether the cost is worth the benefit, usually in those cost-benefit analyses, they're using Viscusi and Ali's value of a human life, their estimates. But he looked specifically at cigarette consumption, and even though smoking causes a lot of poor health outcomes, I'm sure you remember from like DARE class and like basically like the propaganda you get in like elementary school, middle school. Besides the negative health outcomes, people who smoke tend to live a lot shorter lives than people that don't smoke. So what ends up happening is that the shortened lifespan cancels out the increased spending while they're alive. And Viscusi finds that it's about a wash. So people, through living shorter lives, end up spending less money in the long term on healthcare than they would have if they were unhealthy but living that full life. And the jury's still out on the obesity, whether that shortens lifespan enough to account for the increased cost while they're alive or not. I think the textbook mentions like one in the Netherlands found that it does cancel out. One in the United States finds that there still is a negative externality. Okay, so besides Pigouvian taxes, there's another method that the government can use to try to address externalities, try to reduce negative externalities and increase positive externalities. It's called command and control. And command and control is basically what they do. The government can tell people what to do, tell firms what to do. It can ban things. It can require them to do things. They basically tell the people creating the externalities what they have to do in order to reduce it. So one example is the government imposes a limit, an actual amount of pollution that firms are allowed to emit. Or they could tell them you have to use these specific devices. You have to upgrade to these new cleaner machines. For people like what was Trump bitching about? The low flow toilets and the like dishwashers you have to use twice to clean things off. They reduce the amount of water that they're spitting out. So the purpose is to save water, to reduce water waste. It's an example of command and control. In like the late 70s or early 80s, the federal government required that car manufacturers use catalytic converters to reduce the emissions from those cars. Again, instead of using like a tax to make cars more expensive, what they did is tell them you have to do this specific thing in order to reduce emissions. But there's a problem. This often isn't efficient. Sometimes it is. I think the catalytic converter ones is a good example of a time that it was a simple and fairly cheap method to reduce emissions. But you can imagine other times when that's not the case. For producing electricity, some plants were using clean coal years ago. They were extremely efficient. So it'd be difficult for them to lower their emissions. Whereas others were using like dirty coal, they were using old equipment in their factories that were less efficient. So they're spilling out more pollution. And the government said you have to reduce your emissions by 10% this year. Some of them would meet it easily. Ones using the dirty coal, like I think they're usually like in the Midwest, very easily switch over to clean coal and hit those standards. But the ones that were already really efficient, that were already polluting like as little as possible, it'd be very expensive for them to reduce their emissions. They'd probably just have to reduce the amount of electricity that they're producing. So in these situations, command and control can be very difficult. That's one reason in the Paris Accords, where like everyone agreed, or all the major countries came together, agreed to reduce their emissions to try to reduce, I don't know if it's pollution in general or just CO2, to try to stop climate change. You have countries with different goals instead of all the same goal. Because some countries pollute a lot less than other countries, so it's cheaper for some to reduce emissions by a lot, and it's really expensive for some to reduce their pollution just by little, because they're already, so efficient. They're already polluting so little compared to other countries. Now, there are cheaper ways to figure out how to reduce pollution, to reduce overall pollution in like this, still sticking with the like electricity production example. Never mind, okay, we'll walk through the example of car manufacturer before we get back to that. So let's think of two companies, so you have Ford and GM. Ford can reduce the pollution in their cars very cheaply. They're producing really, really inefficient cars. While GM has a very high cost of reducing pollution. So when their production of cars and the cars that they sell, they're already really efficient. They're doing a good job, and Ford isn't. So if we want to lower pollution, if that's the goal, it would make more sense to ask Ford to reduce their pollution more than GM. Maybe GM can still bring it down somewhat cost effectively, but they can only move a little bit. Whereas Ford has a lot of room to very cheaply reduce emissions, or relatively cheaply, say that. So if you're a central planner, if you're looking at this, pulling the strings in the entire economy, you would say, all right, I would make Ford reduce a lot more, because they have the room, they're able to. On the other hand, Ford may be upset by that. Doesn't seem fair. Why are they getting more of a cost of this regulation placed on them? So the efficient solution is Ford do more of the pollution reduction, but have GM compensate for it. Kind of getting back to this idea of Coasian bargaining. So through this, both companies can be made better off. So if you say both have to reduce emissions by 25%, it can be very expensive for GM. But if GM pays Ford some money, less than the amount it would cost them to reduce their pollution, obviously, they can make themselves better off compared to that. Ford can also make themselves better off. They're now getting some compensation for reducing their emissions. So we can reduce the amount of pollution the same and do it at a lower cost, because we're now having GM, who's pretty efficient right now, who's not polluting a lot, compensate Ford for their reducing pollution. Yeah, so this brings us to cap and trade. we had this system in the United States for a while. Basic idea of cap and trade is what they call tradable emissions permits. The government divvied out these permits to all these firms, I guess, in a specific industry, and said, all right, you're allowed this much emissions of certain pollution. Then they set up a market for it. So you were, at the time, able to go on the Chicago Mercantile Exchange, where you buy like futures contracts and contracts for different types of commodities. You could go there at the time, even regular people could go and buy emissions permits. Like if you climate activists went on the exchange, bought some of these emissions permits and just kept them themselves, not so they could open a business and start polluting, but just to reduce the amount of pollution that was going on, because that's how much they valued it. So basically, by setting up this market, they allowed the example from the previous slide to exist. So GM could actually compensate Ford. They could pay them some money. For Ford to reduce their pollution. So GM didn't have to go through a really expensive way to reduce pollution. So firms with a high cost of reducing pollution are going to buy permits from firms with a low cost of reducing pollution. So what we're doing in this case is we're still reducing pollution by the same amount, but we're doing it at the lowest possible cost, because they'll be willing to buy at a cost that's less than what it would be to reduce the pollution themselves. So it's a combination of using a market and government command and control method in order to achieve a much more efficient and low cost pollution reduction. Much lower cost than the regular command and control. Yeah, there's more information here. One of the big problems with command and control is government regulators don't have the full knowledge of everything that's going on, which sounds like a definition, but basically sounds like common sense, because no one person can contain all this information, or no small group of people. They don't know the nitty-gritty details of all the manufacturers, how much they pollute. They probably have a pretty decent estimate on that, but how much it costs them to reduce pollution, how efficiently they're operating, or even what level of pollution they should reach, what level is the optimal. So it can be very difficult to try to figure this out. And we see with EPA, they have their standards changing over time. As they run new cost-benefit analyses, they have more accurate models. They're developed over time. So it can be very difficult and costly, especially if they try, you have some manufacturers that have very low cost of reducing pollution, some with a very high cost. You make everyone reduce, it can be very, very expensive. Cap and trade, this idea ended up being much, much cheaper. I wrote some notes down here for the numbers. It says the improvements in pollution reduction technology resulted. The cost of compliance ended up being 90% less than initially estimated. The more you look at government and policy in general, the more you realize that the initial estimates for cost never end up too high. They're always too low. You always see cost overruns. So this is shocking, not only that they ended up being cheaper, but cap and trade is 90% cheaper than they initially estimated. The command and control method, which they were considering using before they implemented cap and trade, that was their two ideas. Should we do this, tradable permit or emission permit, or should we do just blanket regulation on everyone? The command and control blanket regulation was estimated to cost $7.4 billion. Pretty significant cost for these manufacturers. It ended up costing $870 million, which is 90% less. So it was extremely, extremely cheap compared to the other alternative. And we ended up with the same result. I think that's the important part. that we saved like $6.5 billion or $1 trillion. 6.6 billion dollars, and we got the same exact result. So much, much cheaper. So the program ended up with benefits 25 times the cost of implementing the program. A lot of people disliked cap and trade, had a natural kind of aversion to it. But cap and trade was an extremely cheap and effective way to reduce pollution and to encourage firms to adopt this new pollution reduction technology when it was efficient for them. They would not have done that otherwise. On the other hand, environmentalists didn't like cap and trade because they saw it as a license for firms to pollute, because they thought of it akin to purchasing a permit to rob a bank or to steal someone's car. That this is a bad thing, something they shouldn't be doing, so why are we allowing them to pay just to be able to do it? But pollution does have a benefit. Remember, without any sort of pollution, we wouldn't have a climate-controlled building to be sitting in right now. We'd be sitting outside in the rain. For those of you who live like off campus, you wouldn't be here right now unless you started walking in like the middle of the night. I wouldn't be here right now, but I don't think you guys would be too upset about that, looking at your faces. Pollution allows for production, allows for cheap production. So there's trade-offs involved. There's a serious benefit to allowing some sort of pollution. It's nice to be able to drive a car and get somewhere. But it also has a cost. And when the pollution gets really bad, it can be a really significant cost. Every decision firms face for production uses some scarce resource. Remember, because of scarcity, you have to decide between different alternatives. So for firms, there's time, there's the amount of natural resources used, there's clean air around them, and the pollution that they're creating. There's the actual money cost that they could be spending on something else. All these different decisions. So looking at it this way, paying for clean air seems appropriate because that's one of the things, one of the margins upon which they're making decisions of how to produce, how much to produce. Yeah, so we don't want to reduce pollution all the way down to zero. There is some level of pollution that is beneficial to society because the benefits that we're getting from it outweighs the cost of the pollution. Another concern, and something that's a little more serious than just the perception of these tradable emissions permits, is that cap and trade may produce what's called hotspots. So certain locations where a lot of pollution takes place. There's agglomeration effects where if you have similar businesses located near each other, it can be much cheaper to operate. That's why when you go to like a downtown or like a business section in a town, you see like all the fast food restaurants in a row. The reason being, you have workers that tend to locate close to work. So if you locate near a competitor, you can attract their talent more easily than if they have to move across town or something. People running errands there anyway are going to be more likely to stop in. If you use the same suppliers, delivery becomes cheaper because they're already out making a delivery the store next door. This isn't just true for fast food restaurants like in Breezewood or like Plank Road in Altoona. It's true for manufacturing as well. So you tend to see manufacturing facilities located near each other for very similar industries. My summer job was at a dorm furniture factory, like when I was an undergrad, and there were, Williamsport was not like a manufacturing hub. There were like 3 or 4 furniture places located like in a row within like a mile from each other. Again, they used to take employees from each other. They have a lot of the same firms dropping off things they're using in production. So it makes a lot of sense to locate near each other. All that said, it has this negative effect where you could have a lot of pollution in this narrow area. So you can end up with the entire United States having a lot of pollution reduction, having clean air, not having to deal with smog and soot and all that. But in these locations, you end up getting a lot of pollution. So in general, all of Pennsylvania is pretty darn nice, but Pittsburgh is just covered in soot and ash all the time. This could be the case, even with cap and trade, if the firms with high costs of pollution reduction were geographically close. Now, this may be likely for things like steel. If they're all using the same sort of technology, the same like age machinery, the same type of natural resources, like the dirtier coal instead of like the more clean, efficient coal. It could not be the case if firms opened at like different times, in like different decades. The Industrial Revolution, like Germany had their they industrialized later than Britain did, so they ended up at one point being more efficient than Britain because they had all these machines that were like 75 years newer. So all their factories were a lot more productive compared to the British factories that opened up 75 years before that didn't want to spend the money to get these new machines. They thought it was too costly. So maybe you can see this going on with firms opening at different times, having more and more efficient production over time. So it may be the case, it may not be the case, depending on if they're all the same industry or just kind of similar industries or completely different industries. But definitely a concern. And something that regulators could more easily keep watch over. Fairly easy to tell if there's a lot of pollution going on in one area. And they can either place a pollutant tax on all of those right in the area, or they could use a command and control method to force them all to reduce their emissions. So what cap and trade does is alter who pays for pollution. It changes it from all consumers when there's no pollution regulation. Again, everyone bears the cost of pollution. Anyone who has to breathe the air, drink the water, they end up bearing some cost. The firm that's actually doing it bears very little cost. Really, it's only the employees for them as general people in society get it, like face a cost. The firm itself doesn't have it in their on their financial statements or anything. When you enact cap and trade, the cost of pollution is borne directly by the firms. We've what we call internalized the externality. They're now facing this cost when it was spread out to all these people before. So it's good for people that no longer face this cost. We've reduced the externality on them, but now we've increased the cost for firms. This gets into a little bit of public choice theory that we haven't really talked about, but I think it's pretty intuitive. Firms that pollute, there's a lot less of them than there are people in societies, let's say in the US. So they can organize together a lot more easily. The transaction cost of them organizing is a lot lower. So think of it, if all of us in the classroom as polluters and the entire campus as like the people who live in society, it's a lot more cheap. It's a lot easier for us to organize ourselves together and to come up with something we want for the school. Everyone else in the school, it'd be a lot more costly, a lot more difficult for them to get together. They're not all in the same place at the same time, at least most of us. There's a lot more people, so to find a time to meet takes a lot more time and difficulty because everyone has their own different schedules. We see the same thing when it comes to government, that these very small, narrow interest groups are able to organize together a lot more effectively, and they get a much higher benefit per person. So this is the special interest problem that we see in politics. That's why interest groups can be so demonized so often. Because each person in that interest group gets a large benefit compared to the small cost that's spread out on everyone. Doesn't seem that bad, you're only paying a little bit more for whatever this is, but when you have a ton of special interests, that cost really adds up. Okay, let's go back to COVID until I made this slide like a year ago when people were still calling it the coronavirus. There's a lot of actions that have positive or negative externalities. that are amplified by COVID. So what are some of these things? What is something related to COVID that's a negative externality or has a positive externality? Everyone should be able to think of an example of something with a positive externality. The mask. Yeah, mask is annoying. We face like the cost of wearing it, but we don't get the full benefit. The kind of masks we're all wearing don't really protect us, but they protect other people from us. So what are some solutions we could do to encourage mask wearing? What's that? So encouraging people to wear masks, making it more like a cultural norm. Yeah, people like never wore masks before, like when they were sick. So make it less costly, but like, hey, this is a normal thing. That's one thing we can do. You can go straight up to command and control and tell people they have to wear masks. Might not be feasible, but we could pay people to wear masks. Give a subsidy, so I don't know. The cost of mask is like that you pay to buy is like half. You'll be more likely to buy it. Seems a little more difficult to work out in practice, but like in theory. How about something else? How about going in public sick? That definitely is a negative externality. You don't bear the full cost if you infect somebody else. So what are some things we can do? Command and control, Pigouvian taxes, cosine bargaining. How can we solve this problem?
Like you could do command and control, just force them to stay home or whatever.
Yeah, we did that for a while. Force people, like healthy people, to stay home, or as many as we could. We could rely on cosine bargaining. That'd be a little more difficult, but like firms paying to stay open when the government wants you to shut down. Another thing we did was, I guess you could look at the unemployment insurance in this way, or the increased unemployment insurance in this way, is that we made it less costly for people to stay home. We kind of paid them for the unemployment. That was really seen as a, paying people because we shut down their businesses. As like we did this command and control thing to stop you from going out. So here's some money so you can keep living your life. But we could go even further and say, like, if you have a positive test, like, stay home, here's $100. Vaccines are another one with a positive externality. You don't get the full benefit of being vaccinated. Again, you're not spreading it to other people, so they're getting some benefit. So we'd expect that not enough people would get the vaccine. They don't bear the full benefit of it. So we can require people to get the vaccine. We can, really force them to. Or we could give people a subsidy, pay them to.
Would firms closing be one since they don't have to like rent office space anymore, but then employees can't go to work? That'd be a negative externality.
Firms actually shutting down? Yeah.
Because like they don't have to pay for office space.
Yeah, I'd say so. That's a good one. Okay, you guys have any questions about the end of externalities and the government solutions for externalities? All right. So we'll end briefly by talking about the 4 categories of goods. So far, when we've talked about goods, we've talked about private goods. But there are 3 other types of goods we'll briefly touch on. Now, Again, when I said the market is the best at providing the efficient level of goods and services, the optimal level for society, I didn't make the distinction of what type of goods. It's the best at providing private goods. But there's some issues looking at the other types of goods. The other types of goods are far less common, but they still exist. And in those types of markets aren't the best. There are other solutions that we may need to use. So what type of good it is, how we're going to classify them, are based on two things. First is rivalry, and the second is excludability. So rivalry is when one person's consumption of a good means that no one else can consume it. So if I use a good, that means it's done, no one else can use it. So like if I eat a sandwich, no one else can eat that sandwich. The other is excludability. So in excludability, anyone who doesn't pay for a good cannot consume it. So the hoagie shop I go to, if you don't pay for the hoagie, they don't give it to you. They can stop you from getting it. So for goods that are both rivalrous and excludable, they're called private goods. Yeah, so again, Big Macs, running shoes, things like that. That if I use it, you can't use it, and if I own it, I can prevent you from using it. On the opposite end, there's non-rivalrous and non-excludable goods. We call these public goods. A public good is like national defense or the court system. So national defense is the most common example. So if the military exists and provide protection for me in the United States, they're also providing protection for you. My consumption of that doesn't preclude you from using it. Also, it's not excludable. If you don't pay taxes, they can't not, provide you national defense. They can't single you out. Ronald Reagan, Star Wars space lasers that are going to shoot down the Soviet missiles. If they protect me, they also protect you. I can't stop you. They can't stop you from consuming it. Now, there are also common resources. So these are rivalrous. There's a certain amount. If you consume it, I can't consume it. But they're non-excludable. You can't prevent people from using those resources. The classic example is the pasture, the common land in England. If I bring my goat out to graze on it, I'm reducing the amount of grass in that pasture. But you don't have property rights to it, so you can't stop me from using it. And the final is quasi-public goods. They're also called club goods. These are excludable, but they're non-rivalrous. So if I did have cable TV, if my consumption of it doesn't reduce the amount that's available to you. So I can have cable TV, you can have cable TV, Lund can have cable TV that he watches instead of showing up early. But it's excludable. If you don't pay for it, you can't get it. And you can prevent people from using yours. Yeah, so far, when we've been talking about goods, we've been talking about private goods. And markets tend to be really good at providing these private goods. Because the person that's making the decision about how much to purchase tends to be the only one benefiting, unless there's externalities present. So it's their preferences that matter. They're facing all the costs and getting all the benefit. So they're going to consume the right amount for society. Likewise, producers are getting all the benefit and then paying all the cost of production. So they're going to produce the right amount for society. And we'll produce where the marginal benefit to consumers equals the marginal cost to producers. We'll maximize both consumer surplus and producer surplus. This is our efficient market equilibrium that's so awesome that we want to reach. But for the other types of goods, we don't see this happen. For public goods and for common resources, people can free ride, so they can enjoy the benefits without paying for them. So for public goods, you can just not pay your taxes, and you're still going to get national defense. They can't stop you no matter what. They can send the IRS after you, but they can't prevent you from getting national defense. They can't allow that missile, coming from the Soviet Union to only hit your property and cause no damage to anyone else. You get protected, even if you don't pay. And because of that, no one's going to want to pay. For common resources, there's pretty much no incentive to conserve them for the future. Because if you don't use it today, someone else is going to use it. That's why they talk about, you hear from time to time about the overfishing in the oceans. Because that's a common resource. There's only so many fish out there, but no one has property rights over them. So, because it's like it's owned in common, like everyone has claim to it, people consume as much as possible, because if they don't, someone else will. So let's construct a very simple demand curve for private good, and then we'll do one for public good so we can see the difference. So right here, we have Jill and Joe, and they're in the market for hamburgers. So at the price of $4, Jill's willing to buy 2 hamburgers, and the price of $1.50, she's willing to buy 3 hamburgers. That's her personal demand curve for burgers. Joe's a little hungrier. At the price of $4, he's willing to purchase 4 burgers. At the price of $1.50, he's willing to buy 8 burgers. So we add up the quantity at each price. So at the price of $4, Jill will buy 2 burgers, Joe will buy 4 burgers. So at the price of $4 for the market, we have 6 burgers, 4 plus 2 being consumed. Likewise, at the price of $1.50, Jill will purchase 3, Joe will purchase 8. So the quantity that's being consumed at $1.50 is going to be $11, or 11 burgers. So we're adding out horizontally. But public goods are different. So for public goods, the demand curve, instead of being the private social benefit, is going to be the public marginal benefit. I think I messed up a word there in one of those two. So the demand curve for the private good is going to be the private marginal benefit. For the public good, the demand curve is going to be the social marginal benefit, so all of society. We'll still use 2 consumers. And this slide is really, really small. Okay. So let's say that Jill and Joe own businesses on a very desolate stretch of land. There's not much around them, so they're concerned about someone coming and robbing their place. So they're thinking about paying for private security. Jill is willing to pay $8 per hour for a security guard to provide 10 hours of protection. So right here, 10 hours of protection, is willing to pay $8. Joe, for 10 hours of protection, is willing to pay $10. Now we're going to add these vertically because what's going on is a little different than private goods. So here, for public goods, if there's 10 hours of protection being provided, both Jill and Joe get those 10 hours. Remember, because it's non-excludable and non-rivalrous, if the security guard provides 10 hours of protection, it's going to be for both of them. It's not going to be just for one. So panel C here, this bottom one, shows what this market, a very small 2 individuals, for private security guards is going to be. So at 10 hours of protection, it's going to have the marginal social benefit of $18. The $10 from Joe and the $8 from Jill. So just like for the private good, the optimal level of production for a public good is where the social marginal benefit equals the social marginal cost. But in this case, we can't just take into account, we can't just rely on individuals making that decision. Again, because there's going to be free riders in this market. People are going to try to take advantage of once it's produced, it's out there, they're going to get the protection for free. Yeah, so what makes public goods different from private goods is that individual preferences of consumers aren't revealed in the process of purchasing. What I mean by that is that in the market for sandwiches, a nice hoagie, if the price is $4, you know exactly how many consumers value it at $4 because they're going out and paying for it. For a public good, we don't know this. People aren't able to reveal their preferences because they're not going out and paying for it individually. So we can't use the market to figure it out. You don't go out and purchase national defense. You don't go out and purchase police officers in your community. So the provider of public goods doesn't know the willingness of individuals, their willingness to pay, doesn't know how much they value those public goods. So going back to the security guard example, Joe is encouraged not to reveal his preference. He's encouraged not to actually go out and pay for the security guard. If Jill pays for the security guard, he gets the protection for free. You guys might value national defense. It's nice not to be living in like a war zone, but if you don't pay, they're still going to provide it anyway. Someone else is going to pay for it. So you're encouraged not to directly write a check to the government to pay for it. So once a public good is created, once it's like produced and being offered, the marginal cost for the next person to consume it is zero. So in reality, the first person would pay their value for it. It would be created, and then the cost of anyone else jumping in is $0. So a market wouldn't be able to function when you're doing this. That's why typically the government provides public goods, because a firm would not be able to function and operate. They wouldn't be able to force every individual to pay for it and what their value is. So while in principle, we have a supply and demand curve here for public good, we have the marginal social cost here, the supply curve, and the marginal social benefit here, the demand curve. Consumers are encouraged not to reveal their preferences, so you don't know what this demand curve is going to be. So we can't just use the market mechanism to produce the socially optimal amount. What we tend to use, or try to use for the provision of public goods, is what's called a cost-benefit analysis. So a bunch of economists and some lawyers at a government agency sit down and they do a cost-benefit analysis. They add up all the benefits, put dollar values on it. They'll often use Viscusi and Aldi's statistical value of a human life. They'll look at all the costs, all the benefits, whatever, the other side. And they'll weigh them and see if the benefit outweighs the cost. Other times you have these being done more informally in Congress as they debate what the optimal level should be. But obviously once you get to politicians, there's going to be some measure of trying to do right for your constituents and trying to get reelected in there. And maybe, trying to help out the special interests that donate to your campaign. But in theory, they're still trying to use this cost-benefit analysis. We don't have a market. We don't know how much people value it and how much they actually want. So we've got to figure out some other way to do that. Before we move on, I want to note people typically say that that education, especially like elementary school, high school, that's a public good. It is not a public good, just because it has the name public in front of it. It has a very high externality. The externality for like elementary school education is like super high. Just having a literate society is like has a very high externality outside of what the individual benefit is. That said, it's still not a public good. It's both rivalrous and excludable. There's only a certain number of seats in here, and same with an elementary school. There's only so many like teachers they have, so there's a limit to, there's some rivalry involved. It's also possible to exclude people, just not have them come in, not grade their stuff, things like that. So it has a very high positive externality, but it is not by definition a public good. It's not to say the government should or shouldn't provide and make any sort of judgment like that. Just by definition, it's not a public good. All right, so quickly I'll touch on public resources. common resources tend to be overconsumed. We call this the tragedy of the commons. Basically, you overuse common resources and you use them all up in a very short amount of time. So people can not be excluded from a common resource. Anyone that has access to the common land can go graze their animals. Anyone that has a boat and a fishing line can go out on the ocean and fish. But consumption is virus. There's only so many out there. And once I catch that fish or I graze my cattle on common land, other people can't use it. So we're depleting the resources. Ideally, a Pigouvian tax would work, but it's not possible often for common resources. So we think of the overconsumption as a negative externality. We have the marginal private cost right here, and we have the marginal social cost up here. Again, we're consuming too many. So right here, we're consuming too many. If we bore the full cost of, depleting these resources, the cost would be higher, but the amount actually consumed would be lower. That's why we say there's this overconsumption of resources. So because there's overproduction, we see this dead weight loss, just like a regular situation where there's an externality. So it's the same, comes from the same source as negative externalities, a lack of clearly defined and enforced property rights. Armin Algen said pretty much everything in economics comes down to property rights and stems from it. Because property rights aren't feasible or they don't exist, no one has claim to the fish in the ocean, common resources tend to be overused because it stems directly from that. So there's two solutions. If we're looking at a limited geographic area, and a smaller number of people involved, you can restrict access to the common area or the common resource by using community norms and community laws. Anyone ever have to read Moby Dick? Me neither. I guess we're all lucky. I've heard terrible things about it. But, he's like trying to catch like the whale or whatever. In the whaling industry in New England, there was a small enough number of them that they had these community norms about if you shot, because it took a bunch of shots to kill a whale. Normally it'd swim away. It took a while to find it. The first person to shoot it gets claim on that. They limit themselves to only a certain number of whales. So they use community norms voluntarily to ensure there was not overuse. Over in Switzerland, they have common forests where there's no property rights to the forest. They have very strong norms about when you're allowed to chop down trees, how many trees you're allowed to chop down. And again, it's done on a local level. They do a very good job. We don't see overuse there. But if the geographic area is large and there's a large number of people involved, you need some sort of legal restriction. You need the government to step in through taxes, quotas, tradable permits on access, things like that. So if you want to go hunting, you need to get a hunting license through the state. If not, we'd see deer hunted to extinction. Someone who's hit 2 deer in the past calendar year, I wouldn't really mind that. But it'd probably do bad things for the environment. They're probably needed in the food chain. So when you have common resources, the two ways you can do that is through local community norms and laws, things decided upon locally, maybe not even through the government. If it's large or there's a lot of people, coordination is very difficult, so we rely on the government to do that, using taxes, quotas, things like that. Okay, so that's the end of the section. Do you guys have any questions about the 4 types of resources? With that, I'll bring up the study guide. Do you guys have any questions on the study guide? Anything you'd like more clarity on or another explanation of? I know it sucks. I took a little longer than I thought today. Just 10 minutes left in class, just about. Yeah, go ahead.
Did you draw number 20 on the board?
Yeah. Pull this bad boy. All right. Supply and demand graph where consumer surplus is greater than producer surplus. compare the price elasticity of demand and the price elasticity of supply and see which is greater. Consumer surplus is greater than producer surplus. And right here is our equilibrium price and our equilibrium quantity. So if we have a steeper demand curve relative to the supply curve, now we end up with a greater consumer surplus. So if our demand curve is inelastic or more inelastic than the supply, you end up with a greater consumer surplus. Because there's some people willing to pay a ton of money for that quantity or for that good. So they're getting a huge consumer surplus when the price is at equilibrium. Yeah.
You said this exam is next Thursday?
Next Tuesday.
That's next Tuesday?
Yeah. And I don't like giving exams on Tuesdays because it's like 5 days since you've had this stuff. And it's gonna be just like before, 25 multiple choice questions, and then 5 short answers, and like 1 or 2 bonus questions. Okay. The problems associated with price controls, those can either be the 6 I mentioned from Richard Nixon's head of the price committee, or it could be things we talked about with price ceilings and price floors. So like minimum wage, it reduces the number of people that are employed. So those people don't have jobs. All the things associated with rent control, you have the deterioration of the houses on the market or the apartments on the market. You have a decreased supply over time. Shifting from like apartment buildings, like residential rentals, to commercial rentals. Could be either of those. Just important to note that there are negative side effects associated with price controls. Remember price floor, like agricultural products? The price floor going to go above or below the equilibrium price? Above. Sorry, if you put the price floor below, it's not going to do anything. So the minimum price is going to be above the equilibrium price. So the quantity demanded is going to be here. The quantity supplied is going to be where across that price hits the supply curve. Again, at this higher price in equilibrium, let's call this $3 and this $3.50. Because it's now 50 cents more expensive, fewer people are going to be willing to buy it. Right? There's people, it's now relatively more expensive. People that would buy it at $3 be like, oh, it's not worth it. I can get something else for these $3. But producers over here on the supply curve, they're willing to produce more than the equilibrium quantity. And they're willing to do so because now they think, well, if they can sell it, they'll get $3.50 for this good, whatever it is. But people aren't going to want to buy it. So we end up with a surplus on the market. So we have all these unsold goods sitting there. Normally if this happens and we're not in equilibrium, firms can adjust the price. They can lower the price and move us back down to equilibrium. And they can reduce their production in the future. But with price floors, we can't do that. With price floors, they're just gonna sit at that price of $3.50. So we end up with a surplus. So you have the government paying farmers to let their fields lay fallow. You have them buying the extra or the surplus agricultural product that's being produced, and usually just letting it sit there, like destroy it, instead of like giving it away to people. So that ends up being too difficult. So we end up with overproduction, and then having to spend extra money to deal with that. Any other questions for me to go over?
What were all the chapters covered in this class?
It is 4 and 5. So it's producer and consumer surplus, and then externalities. Yeah, so there'll be a question about like public good. What is it? The easiest one, national defense. I know that's non-rivalrous and non-excludable, so you have the problems where the market doesn't work. U.S. drug policy, because it's not in the textbook, is the supply side or demand side focused? Or supply side focused? And it decreases the demand for drugs a little bit, but remember, there's a very price inelastic, the demand. So you end up with a small reduction in the quantity demanded by consumers in the market. You don't have any other questions, you guys can take off. If you do have any questions,